Can we start now, Rajesh, or you want to wait for some more time?
Yes, sir. Just 1 minute, sir. Okay, so good evening to all. So today we have with us Dr. S.C. Srivastava. Sir is Life Fellow of IEEE. He is Fellow Indian National Academy of Engineers. He is Fellow of Institution of Engineers. He is Fellow of Institution of Electronics and Telecommunication Engineering. Sir received his BTech and PhD degree in Electrical Engineering from the Institute of Technology, BHU, and Indian Institute of Technology, IIT Delhi, respectively. He has been professor with the Department of Electrical Engineering, IIT Kanpur, till 2020, and as a director, IIT Kanpur La Trobe University Research Academy, and distinguished visiting professor till November 2023. He also served as program director, IIT Kanpur SIIC first in its Noida office till June 2024. Sir's research interests include power system stability and security analysis, synchrophasor applications, power system restructuring, and smart grids. He has served in the governing council and expert committees of several government organizations like academic institutions and utilities in India, and received several awards, including Academic Excellence Award and Malvi Award for Excellence in Power Systems at NPSC. His Distinguished Teacher Award and Institute Fellow Award of IIT Kanpur. So now I request Sir to conduct his session. Sir, please.
So thank you, Rajesh, for nice introduction you gave. I am really excited to talk to you, all of you, on this particular topic, which is emerging topic on sustainable and smart distribution systems. So smart grid is already well known. I think since 2009, this terminology has come. I will give very brief introduction about that, and would like to take you what are the changes taking place to make our power system sustainable, what are the challenges we are facing, and particularly in distribution system where we are going to integrate a lot of renewables, renewable sources plus storage. Together we call them renewable energy resources, and how we are going to design that. I will also give one practical example, which is based on our experience in one of the Indo-US project. UI Assist was the short name of the project, where we really implemented a couple of the smart grid pilots in rural area, suburban, as well as urban areas. So with this, I think I would like to start my lecture to take you that now these days, everybody talks about sustainability. Sustainability in energy, sustainability in transportation, every walk of life, you want to be sustainable. Now, this is not a very new terminology. In fact, formal definition came in 1987. If you see on the left-hand side, the UN Bertland Commission gave formal definition, very short definition, that while meeting the need of your own at the present time, you don't compromise the ability of the future generations. Don't eat away all the resources which are available in the nature. So you care for the future generation also. So that is the whole motto about this sustainability. But then several other definitions, very detailed treatment came, including one of the report published by Michigan State University. It was in 2002, where they say that sustainability is the intersection of three aspects of the development. One is you are caring for society, including their standard of living, education, job, equal opportunity. You are also caring about economic development with respect to growth, profit, cost saving, and R&D, and also respecting the environmental call, which says that you have to, natural resources you have to preserve, pollution has to be reduced, biodiversity also has to be preserved. So this is a very broad definition where 3 dimensions of sustainability have been considered. And then intersection of society and environment is the social environmental concept. In power sector, we also talk about economic environment, where green technology is involved. Renewable fuels are involved. So I will be talking more about that. Now, you can stop me anywhere whenever you feel like that you need some clarification. Now, 2015, United Nations gave very detailed report and 17 Sustainable Development Goals, SDGs, very popularly known as SDGs, they had given, where they talk about removing poverty, hunger, health and well-being, then education, every aspect of life, whether it is on the land or below water or in the air, so they have addressed. And the SDG 7 is very important in power sector, where they talk about affordable and clean energy. And one major clean energy form is the renewables. I think most of you may be knowing, and yesterday I believe you had a talk on that. And that is called also the green resources, the green sources. Now, when you talk about in general green energy technology, it is not only limited to renewables. It also includes in power sector, improving energy efficiency, energy conservation, sustainable transportation. This is again, we are talking large deployment of electric vehicles, e-mobility in maybe railways as well as road transport everywhere. So how to develop them and how they become sustainable is the major concern. Now, when you address through green technology the environmental problem, this needs various innovations. With respect to technology development, like solar energy, new technology has to be developed. Wind power also, low wind power generator have to be developed. Storage, I think, is the weakest point we have, where new technology has to come up. And in grid integration through power electronic converters have to be deployed. Sustainable transportation, I talked. And this will provide a lot of benefits like to environment, energy security, like your dependence on the other country and the other type of sources reduces. And it improves the quality of life. But to achieve that, you have several challenges and have to be overcome. Like cost is one issue. Like everybody talks that it will become very costly to deploy a battery and solar. So how to reduce the cost? And then how it becomes scalable. For that, you need a lot of policy and regulatory framework to be in place. Now, if you see the present power sector, I think it is at a very exciting stage. And key drivers are that now new materials have come up, which are being used in developing various type of devices and subsystems, as well as the technology are being developed to create new systems. Like a smart system is a combination of the IT technology and your power sector. So then environmental concerns are there. That is forcing you to change your the equipments and also the operation of the whole system. Everything is becoming market-based, where competition has to be brought out. So if you take few examples like power electronic, if you see the materials over the years which have been developed, now we are talking about gallium nitride and silicon carbide. Earlier we talked about the thyristors using silicon diodes. Now signal processing tools, sensors, IT technology, a lot of microgrids are coming up. Renewable sources are being deployed. EV is being increasingly used, which requires a lot of charging infrastructure. And this will also pose challenge to your distribution network and transmission network. Now, all these, for proper operation, you need automation at every stage, whether it is a wide area monitoring system, distribution management system, or advanced distribution management system. And if it is a market-based operation, regulatory changes are to be put. But one important thing you should keep in mind that where whole world is now concerned, is the environment. Now we are seeing global warming coming up. The climate change we are also witnessing. Now, why it has come up, I'll discuss very briefly. And whole world is committing to become net zero. They have set certain goals to ensure energy security and also preserve the environment. Now, net zero again is a relatively new term. Everybody is talking.
Sorry for
Now,
interrupt, sir. Voice not clear.
voice not clear? Okay. So is it clearer now?
I'm not audible.
Hello, now is it audible? Is it audible?
Sir, audible to us. I think Dr. Sahu has some problem with his hand only.
Okay, I'll put my microphone. Let me tell. Please tell whether it is. Hello? Hello? Hello?
Yes, sir.
Is it better?
Sir, previous was better.
Previous was better. Dr. Sahu?
I think problem is with hand of Dr. Sahu only because we are able to hear you. Your voice is clear.
Go to the earlier one.
Yes.
Is it better?
Yes, sir. Better.
Dr. Sahu, please check at your end. I think if that is the only problem, I think you can just locally see. So net zero goals. Now a lot of international bodies are involved, like UNFCCC, United Nations Federation of Climate Change, then IPCC, International Party on the Climate Change, and so on. So every year or very frequently, the parties are meeting together. They are called COP meetings. And in 21, they met, December 21, 2015, COP 21 meeting was there, where they discussed the environmental problem in more detail and the gravity of the situation also they judged. Now, they said that if the Earth becomes 1.5 degree warmer than the pre-industrial era. Pre-industrial era is 1850 to 1900. Then it will create a lot of havoc to our environment. At present, it has already become warmer by 1.2 degrees Celsius. So only 0.3 degrees left. Now, so people are really panic. So they want to address this problem. And the whole world, they want to be net zero by 2050. Now, let me clarify here. Net zero doesn't mean that you don't emit the greenhouse gas. Greenhouse gas, carbon dioxide is the major contributor. There are many other greenhouse, like SF6 also is a greenhouse, which is more dangerous to the environment, but the quantity is very less. Like we use in the circuit breakers and sometimes in transformers, but the emission is quite less. But intensity is very high. But carbon dioxide is being produced out of the power plants, thermal power plants, transportation system. You also exhale carbon dioxide, and even the plants during nighttime, carbon dioxide they exhale. So that is the major contribution to the greenhouse gas emission. So if it becomes 1.5 degree, then it's going to be dangerous. So the COP21 meeting, it was decided that the whole world will achieve net zero by 2050. But India said that we are a developing country. We promise you to become net zero by 2070. Now, in power sector, energy sector particularly, the greenhouse emission contribution is quite high. And if you replace coal, gas, and oil-fired power with renewables, such as solar and wind, that will drastically reduce the carbon emission. We are not going to close these plants, but we are going to increase the share of renewable sources. So whatever carbon dioxide you emit, if you are able to store them in another form using some kind of carbon capture techniques or you are using more renewable sources, which are reducing the carbon footprint, or you are planting a lot of trees, which also absorbs carbon dioxide, and you are making it equal to the emission, then it becomes net zero. That is the meaning of net zero. So whatever you are emitting, you are able to absorb also. So by June 24, 107 countries have actually, they have promised to become net zero. And that takes care of 82% of global greenhouse gas emission problem. But many of them have already put a law to implement it. Some of them are formulating policy document, and some of them are under discussion. So that is the stage of net zero. India wants to become in 2070, but they want to become energy independent by 2047. Okay, that is the call as Amrit call. Okay, it's 100 years of our independence. Now, renewables, I said that one factor is the environmental factor. Because of 1.5 degrees Celsius temperature rise problem anticipated, we want to have a lot of deployment of renewables worldwide. But other major contribution is the prices have come down. Now, 10, 15 years back, the solar generation price was more than 10 rupees, 12 rupees. Now it is in the band of 2 to 3 rupees, which is competitive with any conventional sources. So it is very, very economical to go for this kind of sources. The only weak point is the storage. Now, development of new efficient interfacing converters have also taken place to balance the power you need, wide area monitoring and automation system, and ICT technology is being deployed for that purpose. So these are some of the key drivers for renewable energy sources growth. Now, IRENA is another agency, International Renewable Energy Agency, which brought very nice document in 2021. So this link, if you click, you can download freely. Actually, you can read. If you are in this area, you must read this document. Now, they have given pathways how to prevent this 1.5 degrees centigrade rise problem. And one of the contributor is the renewable energy. Variable renewable energy, VRE, means solar and wind. And renewable energy includes other forms of renewables which are listed at the bottom. So it says that in terms of capacity, you must reach to 92% so far as renewable is concerned. But this also includes the large hydro. Okay. But this needs a lot of policy in place and also a lot of investment. So you see, anticipated investment is $1 trillion till 2030. Now, coming to India, I believe that you have been given some glimpse of Indian power sector yesterday. But nevertheless, I would like to repeat few points which might have not been covered. Now, India, for operation purpose, have been divided into 5 regions. Power sector is divided into 5 regions: Northeast, Southwest, and Northeast. Now, each of them have control centers called a regional control center. So Northern is in Delhi, Western is Bombay, Southern is in Bangalore, Eastern is Kolkata, and Northeastern is Shillong. Each of the region has different potential of the sources. Like if you look at Northeast, they have high hydro potential. Mountain terrains are there. Northern region also has the hydro potential, but runoff river hydro, like small hydro, is also possible. But weather is quite adverse there. Floods, fog, and thunderstorms are seen there. Now, coming to Eastern, they have a lot of coal reserve. Western, they can go for a lot of renewable, like wind and solar, but large loads are sitting here and also in Northern region. Southern also has relatively less than Western, but load is high. But it has high potential of the wind and also solar. And it has industrial and agricultural load. So there is a diversity in every region. So that was the driving force to interconnect all the regions. And in 2013, 31st December, the whole country became a single synchronous grid. So all of them are operating connected with AC grid. So we call them as single synchronous grid. It is the largest in the world single synchronous grid. So the reason is that different resources you want to optimally utilize available in different regions. That needs a lot of transmission line to be put across the region. Particularly, it is challenging to put transmission line between northeast and eastern region because it has very limited land area. So one side is Bhutan, other side is Bangladesh, Nepal. So this is called chicken neck area, where only 23-kilometer long land is there. Transmission line, any new transmission line requires right of way. So that is not possible. So that is the reason we had gone for 800 kV HVDC coming from northeastern region, and it is a multi-pole. So one line goes to southern side, other line goes to northern side. That is the highest DC voltage, HVDC voltage we have in the world. China also has 800 kV DC. This one single line can carry 6,000 megawatt. That is the capacity. AC, if you take counterpart, 1200 kV AC also we have conceived. One line is already there, but it is being operated at lower voltage. Earlier, it was planned to have one more line from northeastern region to the other part of the country, but that is yet to take place because of the cost and because of the less load requirement for the power to be carried out. Now, this I think the people must have told, or some of the speaker must have told. As of November 24, the installed capacity is 556.757 gigawatt. I believe by now it must have gone to 460 gigawatt, out of which the renewable capacity is 158 plus. Or if you consider hydro also, it is more than 200 gigawatt. So almost 45% we have renewables, 40 to 45% we have renewables in our system, so far as capacity is concerned. But our generation from renewable is relatively less. It is about 15%, 12 to 15% only. And solar is growing at a very exponential rate. It is 94 gigawatt here as of November 24. But renewable target is 500 gigawatt by 2030. That is the plan in the country. So it is very challenging to install such a high renewables and also maintain various quality of supply as well as the stability of the system. Now, region-wise, if you see the breakup, southern has more than 40% renewables, western and northern around 30-35%, and eastern, northeastern is relatively less, but it has to grow actually. But they have also have the solar potential. We are one of the strongest transmission lines we have, which includes 800 kV AC, then DC, I said, 800 kV, 500 kV, and 320 to evacuate specifically the wind power to longer distances, and then 400 and 220 and below. And inter-regional transfer capacity is about 118 gigawatt as of now, but this needs to be strengthened again. So that is the transmission and renewable scenario in the country. Now, renewable is good to prevent the problems associated with the environment, but it has a lot of challenges. One challenge is that the output of renewables, particularly if you see, I will focus only on wind and solar. It is quite variable and intermittent in nature. This is a typical graph showing the daily variation of the solar generation. And if you have cloud, you see the output reducing drastically. And this is the typical plot of Tamil Nadu wind plot over different months. You see a lot of variations there during a day. And whole country, all India, this is the wind variation, and 3 of the regions, the variations are so here. So it is quite variable over the day. So that creates challenge in load balancing. So load has to be balanced all the time, minute to minute. And if the output from such a large deployment or renewable is variable, then other sources have to come up to save it. And also the load flexibility is required. So we talked about flexible generation and flexible load to be brought in. It is also not very easy to predict the output for next day. So you need very strong forecasting tool for all the renewables to be forecasted, very location specific. And the converter-based interface, which is being particularly to solar, creates inertia-less sources. So like conventional sources have synchronous generator, they have inertia, they have rotating parts, but this doesn't have any rotating part. And inertia is good for the stability of the system. Whenever disturbance takes place, if inertia is high, the disturbance will be less. Frequency excursion will be less. Whereas if you have less inertia, the frequency change will be higher. So stability, security, load balance are one of the major challenges. Other challenges are power quality maintenance, because power converter will introduce certain harmonics. And it is the only power converter which also overcomes these problems with proper control. Voltage and frequency control. Protection also becomes difficult. I will just tell you in a few slides why it is difficult. Okay. Now, to take care of variability, I said you should have flexible generation. Even the thermal power plant, we say that ramp rate has to be increased. It should come up in the system in a few minutes. We generally use hydro, which comes very fast, or the gas-based, but gas-based generations are reducing in our country. So, but we need thermal generators are being forced to change their control to reduce the ramp rate. So flexibility has been mandated in that. Then we are also talking about loads to participate in the whole overall management of the system. Flexibility in the load also has to be exploited. The equipment which can also be highly useful in taking the variability is the energy storage. Now, grid level, mechanical storage is feasible. Like pump hydro, we have some installations, and large number of installations are now coming up. In Europe and some of the countries, compressed air energy storage have been exploited. So compressed air, like pumped hydro, what you do, that during off-peak hour, you pump the water from lower level to the reservoir, and during peak hour, it acts as generator. So during off-peak, it acts as a motor. During peak hour, it acts as a generator, so that peak can be reduced. Similarly, compressed air compresses the air in a container which is normally underground at a higher atmospheric pressure during off-peak hour, and during peak hour, the same air is utilized at a higher pressure to run it as generator. So this is also a technology which have to be exploited in our country. People say that it needs a lot of space, but the open cast mine, which leaves a lot of empty space below the ground, can be utilized. I think these ideas are being given. We also discuss in different forums. Second is electrical storage, supercapacitor and superconducting, where we have got success to certain limited capacity. So they are very small size, but biggest advantage of supercapacitor is take care of the transients. Flywheel has not taken up that much. Then now people are talking about green hydrogen, using green hydrogen fuel cell generators. So this is one of the future storage which will come up once green hydrogen is successful. The most successful is the electrochemical storage. Lead acid battery is already mature technology. Lithium ion is being used in almost all electric vehicles, also in some of the microgrids. Sodium-based battery is being developed, and I am sure that this will succeed. Zinc and sodium-based, that is the future batteries. Flow battery, where the two cells are like it is a process plant. Two cells are put separately. And this also is a promising. It has some initial problems, but now it has been overcome. So this also may come up. So this is the stage of the energy storage. And let me tell you that as at present, the weakest point is the storage in our system. Only successfully the pump hydro, but this is dependent on the site. Not everywhere it can be put. Whereas like batteries can be put everywhere, but it is costly, it needs replacement, and it has the disposal problems. So that has to be overcome. Now, very briefly, what is the smart grid? Actually, 8th January 2009, Barack Obama was the president of US. I happened to be one visiting professor in one of the US university, and I was teaching one special course on power system. And that day, he announced the smart grid concept. Earlier, it was known as intelligent grid. EPRI used to call it as an intelligent grid. Once you put IT infrastructure, they used to call it as intelligent grid, but it was renamed. Smart grid was given. A lot of funding came at that time. And very nicely, it was described in different actually newspapers at that time. Incidentally, 9th January, I had a class in the morning and I gave a lecture on the smart grid. So very next day, I gave introduction to smart grid. So the idea is that every part of the power sector, whether it is generation, transmission, distribution, or customer operation, becomes smarter, becomes energy efficient. So, but IEEE gave formal definition. It says that smart grid is a large system of systems. So basically, it combines power and energy layer with communication layer and decision support layer, which is IT computer layer. So 2 and 3 are the enabler. Communication and decision support layer are the enabler to the smart grid. And you want to have best utilization, optimal utilization of all resources. That is very basic definition. Now, a human analogy I also give normally, like your arteries, which are carrying the blood from being pumped through your heart. Heart is a generator. This is your energy system. Now, what makes you smart? It is not enough. If you don't have nervous system, you are a dumb person. So what makes you smart is your nervous system, your sensors like your hand, nose, ear, eyes. These are sensors which are sending signals through your nervous system to the brain. Brain is the computer system or decision support system, which is making you smart. This is just symbolic. Don't become this one. So you become only smart. Okay. So this is the analogy with respect to human being. But coming in a very detailed manner, what are the attributes of a smart grid over the conventional grid? I'll go through the only last line you can read. So it talks about what type of architecture the two have. Like conventional has vertical structure, integrated structure, whereas it will have distributed structure. Customer participation is very important in the smart grid. So customer participation will increase in a smart grid, where it was not, absolutely not there in earlier grid. Now it will have plug and play feature, like DRs can be added anywhere, any number. Power quality will become priority. Market services and customers will improve. It will have predictive tool, like I said, the load forecasting tool or predictive asset management tools will be there, where a lot of data will be used, taken from the communication network and sensors. It will have self-healing. Self-healing, I just want to explain that if some fault is developing, it also automatically creates a control to correct it. So that is self-healing. Okay. It is automated, and fault is also predicted online. So it is self-healing type, where no self-healing is there in normal network. Now, just continuing, it is resilient to cyber attacks. So once you add cyber layer, a lot of cyber attacks are possible. So resilient cyber security measures have to be put. It is response is better here to disasters. So if some, let us say, cyclone has come up, so it will sense quite fast, and also response will be given online. It will have a smart analytical tool. The most important thing is that it should have two-way communication. It will send the signal to your brain or to computer, and also receive signal to the your devices for any corrective action. Then prediction will be there, intelligence will be built everywhere, and energy focus will become priority in smart grid. So these are some of the attributes. Now, this picture shows that in conventional grid, like this is the blue line, light blue, the power flow was normally unidirectional. It was going from large generator through transmission distribution network to the loads. Now, with the renewable sources connected everywhere, both at transmission and distribution level, now the power flow will become bidirectional. Power flow can become bidirectional. So, and to control it, you need bidirectional communication network that is shown in the red, and the control center to be in place. Now, this also tells you that the protection which you have been designing, considering the unidirectional flow of power, say for example, you were grading the relays. Like if there is a fault in distribution, that relay should trip first. Then the next layer as a backup, and the top layer. That is no more valid because the direction may change. So you need adaptive relaying, or you need some kind of directional relay to be put. That is one of the reasons. So bidirectional power flow is one of the reasons creating challenge to the protection system. Second reason is the converter interface, the renewable sources, they reduce the fault level. The initial fault level is very high, which is for few microsecond or millisecond. But then final fault level is quite low. They limit the fault level. So it is very difficult to distinguish between the fault and the normal operation. So these are the two challenges which protection system is going to face: reduced fault level and also the bidirectional power flow. So that makes it difficult. So challenges with the smart grids, as I said, that you need fast communication, cyber security, the big data management you need automation at everywhere. Whole system monitoring, wide area monitoring is required through SCADA or distribution management system. Converter topology has to be selected along with proper controls. Energy storage, you have to site and size properly. Now, it is not enough to put one big storage at one place. That, and also very large size, which is never being utilized. It will act as a load for charging only. So you have to utilize optimally the energy storage, both to feed the load and also for its charging purpose. And it needs to be distributed. Then you need flexible generation, thermal storage, other kind of storage, adaptive protection, regulatory changes. Most important thing is that customer also should accept this change. And this we have faced in our pilot. I'll just discuss on that. Okay. Now, there are very good standards which have come up for, let us say, for interoperability and communication. IEEE 2030, published in 2011. It's a very nice document, actually. So at different levels, like whether it is a local area network or home area network or distribution substation network or the bigger substation network, what should be the protocol and what type of communication we should go ahead, very nicely described in this particular standard. So you may go ahead and read this standard. So just summarizing the changes now distribution sector is facing. One is large solar PV and wind power is being deployed, both rooftop and ground mounted. By the way, the government of India has announced that 40% will go in the form of rooftop and 60% will be ground mounted renewables, specifically solar. Metering and ICT infrastructure is being increased. Unfortunately, it was missing earlier. Now smart meters and ICT infrastructure, but they have to be optimally utilized. Microgrid is another concept, which I will discuss a little later. This is being promoted at community level, like a village, remote village, or a strategic location, very important, like defense location. You can go for microgrid or remote area. Energy storage to take care of the variable output of renewables. And another challenge we are going to face is EV charging infrastructure and its integration in the network. Now, just imagine millions of cars, if they are being charged at the same time. Let us say they are rated for 3 kilowatt power consumption. So 3 million kilowatt is the power they will be drawing. Peak power they will be drawing. So that will create a lot of challenge to distribution sector. So this has to be taken care. So a lot of proper controls are required, or the scheduling is required. So with these changes, the distribution network, which was unidirectional power flow, it was passive network, it was not, customers were not participating in its operation, has now become the active network. With a lot of intelligent devices, communication network, control centers in place, and various devices to improve the voltage like STATCOM and automatic meter reading, and the renewables causing bidirectional flow. So, and also the customer participation through smart meters are being seen, and this will increasingly happen. An active distribution network we will witness this very soon. Now, a brief about microgrid. Microgrid is a small grid, micro size of big grid. So if we say gigawatt, micro size of gigawatt, that is about 10 megawatt or 1 megawatt or maximum, or 100 megawatt maximum, is the size of microgrid. There is no clear-cut demarcation between microgrid, nanogrid, and the big grid or mini grid. So depending on this relative rating, they are classified. But the idea is that if you can form a local grid with generators, storage, loads, and controls, that is called microgrid. For example, a village having solar, its own storage, it has load, and you have controls in place, so that if grid is not there, it survives. If grid is there, it is synchronized. So that is the idea about the microgrid. Now, this is important because it offers a lot of services to utility grids, like it reduces the peak, it helps in voltage control also, because it can inject reactive power through proper controllers. And then black start. I was one of the committee member in 2012 blackout to investigate the cause. And it was found that the first day on 30th July, where Northern Grid failed, we became under blackout. And 31st July, three regional grids were under blackout, except Southern and Western. All three were under blackout. The restoration time was 14 hours and 8 hours respectively. Why such a long time to restore the power? Because the railways were stopped and there was no activity left. So because there was no black start power. So to restart a generator, you need some power, auxiliary power. So that was the difficulty. Suppose you have a lot of microgrids which survive in isolation. Then you can have black start power available everywhere, and very quickly you can restart the generators. Or if you have some natural calamity like wildfire in the developed countries we see, or some kind of cyclone, then certain part which has microgrid gets survived. But conceiving microgrid making it operable under islanded operation requires a lot of controls and a lot of challenges to be addressed. Like islanded operation, from grid connected to off-grid mode, it should smoothly transit. Then grid integration issue, stability issue because it will have inertialess generation, voltage, power quality, and protection issue because of the bidirectional and low fault level. So these challenges have to be addressed when you conceive a microgrid. There are many standards which have come up. IEEE standard, IC standards are there. They are listed here. Once you get this slide, you can go through some of them. Now, with these changes taking place in a smart distribution system being conceived, where renewables are being integrated, 3 levels of controls are required. One is at converter level. So every converter which interfaces to either storage or to renewable should have voltage and current control loop, maximum power point tracking because you want to extract maximum power from renewable sources, droop control if they are sharing power, harmonic and unbalanced control. If you have microgrids, then microgrid level, you need optimal sharing. If you have more than one sources or even battery, you want to optimally share with the PV for balancing purpose. Storage, optimal charge discharge control is required. Islanding detection and management is required. Voltage and stability control is required. These are some of the controls I have been listed. So that is called microgrid energy management system, local microgrid control center. By distribution level, where a lot of microgrids are interfaced, a lot of renewables and the storage is interfaced, you need distribution management system. So you might have seen the distribution and some of the utilities, they have their control center, SCADA center. So they have distribution management system. But when a lot of renewable come, renewable management becomes difficult. So you need advanced distribution management system for renewable forecasting, renewable controls, voltage war control, reconfiguration. So if, let us say the losses have increased, through reconfiguring the network, optimally reconfiguring, you can reduce the losses or voltage you can improve. Fault detection, service restoration, or if you introduce a market, local market, which will come in future at distribution level, then market-based control also is required. And as I said, the protection becomes challenging, specifically if you have DC microgrid. Some people talk about that, pure DC microgrid, although very few deployments are there. In some of the villages, I think the CDAC has installed one of the, in southern region, pure DC microgrid, but at a very low voltage, 48 volt. If you go for higher voltage, the protection becomes very challenging because the rate of rise of voltage due to capacitor is very high here. Now, converters are not only to interface, but it has a lot of other capabilities which have to be exploited. If you have solar generates only real power. Now, where do we get reactive power to control the voltage? Now, actual reactive power injection is not required to control voltage. Like StatCom, you inject a current which is at 90 degree to voltage, which has similar effect as injecting reactive power. So that capability can be exploited by reducing slightly the real power output. You can generate some reactive power. This is a simple PQ curve of a converter interfaced, let us say solar system. So the same solar inverter, smart inverter, it is called a smart inverter, or you sometimes the new concept is coming, the load forming converters. Load following, it has been load following means that if the grid is there, the solar will operate. If grid is not there, solar will not operate if you don't have any battery. But grid forming will continue to operate, creating a reference voltage. So they will have this feature, and also smart inverters do have this feature. So reactive power control can be designed through converters. Now, other problem, as I mentioned, is a stability problem. If you have a lot of renewables, the frequency which was limited here, frequency change which was limited here, if you have less renewables, will be very wide because inertia is less, will be very wide if a lot of renewables are integrated. This is example of 100% renewables. This is just symbolic, okay? So frequency problem, control problem will be there. Now to achieve that, there are two approaches. I'm not going into detail. One is called virtual synchronous generator approach, where you emulate generator. You are not putting actual generator, but through power electronic converters, which are interfaced to battery or renewable sources, you are emulating the behavior of inertial response of a generator, okay? So that it is controlling the frequency. Or you can modify some of the controls of the converters, like PLL controls. So a lot of research papers have come up in this area on virtual inertia emulation techniques or virtual synchronous generators concept. So if you see, if you don't have this virtual synchronous generator, the frequency change is higher. This is called nadir frequency, lower frequency, which improves if you have inertial controls. Okay. Now I'll just give you few real examples which we have done in our Indo-US project. So it was a big R&D project where Department of Science and Technology from India through Indo-US Science and Technology Forum, they supported the Indian team consisting of 15 partners, and US Department of Energy, they supported to US team consisting of 16 partners. IIT Kanpur was lead from India. I was the lead PI for quite some time before I retired. And then Washington State University was the lead from US side. There were a lot of other IITs like IIT Delhi, IIT Madras, IIT Roorkee, IIT Bhubaneswar, TEVI, which is in Delhi, and a lot of utilities, NTPC Netra, BSES Rajdhani, Power Grid, UP Power Corporation, and the industries were partner, and one NGO was also our partner. Similarly, they had the Texas A&M, MIT, West Virginia University, Hawaii National, a lot of national labs like Berkeley Lab, NRL, and PNNL, and industries were involved. So this was a 5-year, 6-year project, continued up to 6 years, where we wanted to conceive all the aspect of smart distribution network, carry out R&D on every aspect, and also demonstrate through some pilot projects. So we did a lot of R&D. We published more than 400 papers together in good journals and conferences. With respect to storage sizing, siting, and its control, the optimal charge discharge, scheduling of the microgrid and distribution network, converter design, microgrid protection, then forecasting, advanced distribution management system we have developed and implemented in our IIT Kanpur campus through, along with one industry partner, that is Synergy Systems here. Then a new concept which is going to emerge in coming future in India is distribution system operator. Like we have system operator in transmission. POSOCO, now named as Grid India, is a system operator. So in distribution, several system operator is required to manage minute-to-minute balancing of the renewable energy along with other system. So that framework we brought out. And then we also did work on the cyber security, the policy aspect, social aspect, and now the approach we followed is that all the R&D work was tested in the lab level first. We also created some benchmark. One IEEE benchmark is coming up. In future, you can use it for your research. And then we implemented in the field. So every aspect of R&D was first tested in the lab test bed. There were 6 lab test beds in India and 6 in US that were created. And then it was implemented in the site. There were 10 pilots which were implemented, and this is the test bed actually in our lab. So we have all real-time simulator, 3 types of real-time simulator, RTDS, OpenRT, Typhoon, and this is the amplifier, big amplifier, power amplifier. The chamber you are seeing is the scaled down model of the smart distribution network. We have created that where solar PV and wind we have emulated, and also distribution network we can reconfigure and connect to real-time simulator through power amplifier to validate our results in real time. So that we did. Modifications in algorithms were also done, and some of them were implemented in our pilots. So there were 5 pilots in India and 5 in US. We divided into 3 categories: rural pilot. This is the actual Kanpur village pilot. I will talk in more detail. Semi-urban pilot and urban pilot were not the actual pilot, but they were replica in our campus. And one suburban pilot or semi-urban pilot was done by Netra in their campus, where 4 megawatt of solar and 1 megawatt hour of battery, along with hydrogen generator, the municipal waste generator, they had put in their campus to make their own campus the free from the grid supply. That is their aim in future. They want to become independent. Now, in Delhi, actually, 3 urban pilots were implemented along with the BRPL, which is the utility there, local utility in New Delhi. And TERI was the implementing agency. So they have tried to see the potential of the storage in reducing the overload of transformers in feeder level. Residential area, one society in Dwarka they have implemented, where they were using diesel generator as a backup. So that was replaced through batteries. Institutional area, their own institution like TERI University in Vasant Kunj, Delhi, they have implemented. They had solar, but it was not dispatchable. So they made it dispatchable. And many other features they tested, like time of day tariff, if you introduce, how it is going to operate, what is the demand response, and so on. I will focus only on 3 pilots which IIT Kanpur coordinated. And similarly, in US, 1 rural, 2 semi-urban, and 2 urban pilots were completed. Now, coming to our rural pilot, which we are very proud of. Now, if you see rural electrification in India, we have about 6 lakh villages. And almost 65% of population lives in villages. That is the statistics given. December 2018, PM Modi declared that all villages are electrified. But the fact is that every village got the electrical connection, and certain percentage of the household were electrified, minimum 40%. Now they are trying to go ahead with completing all the household. But many hamlets, so village is a bigger village, like has cluster of houses which are called hamlets. Hamlets are Purva, whatever you call it in Hindi. So some of them were not electrified, and the reliability was poor at that time. They also brought out microgrid policy to electrify the rural village, specifically the hamlets, and many states have already formed their policy. Some of the private players, but Tata Power and NGOs, they were setting up microgrids. So in this particular project in Kanpur, we found 1 village, big village, having 4 hamlets. 2 were having access to electricity, 2 were not electrified at all. So we said that we will select these 2 hamlets to electrify through our microgrid concept. So we did a lot of survey to find these villages through our NGO. We had a series of meetings. I'll talk a little more about that. Then we designed the microgrid, but the problem was that there was no electricity. How do we know that how much electricity they will consume? So we did a lot of survey with them about their aspirations, how much electricity they will use. which was not very clear, but we also got some idea from the nearby villages which were electrified. So we say that if you have n number of people here, n number of houses here, similar figure we can take from the developed village. And then the local utility like DVNL was the distribution company of UP Power Corporation. They were also our partner. So they said that they will put line and provide a transformer and take the wires to every house, put the meter. That was their responsibility. And we will create microgrid, which will make it self-sustainable and also utilizing the local resources which are available. So we carried out a lot of studies. Land acquisition was a problem. It took almost 1 year to solve. And then how will it sustain after the project is over? IIT Kanpur is no more in picture after project is over. So we formed a local society where predominantly village people were there. And then 2 members from IIT Kanpur, one from the NGO, that is the society governing body. And then they will manage the whole operation and local billing. That was the idea, but now the concept has changed because the the village, the operation becomes difficult. So the utility will take care of billing, but the microgrid will be operated by our UP NEDA, actually, the Renewable company. That is the latest development. Now, when we did survey, they said that more than power, we also need irrigation, water. Only one pump was there in all the 4 hamlets who were charging at a very high rate to provide power, to provide the water. So with our committee, we discussed this problem and 6 solar standalone solar pump we provided. We said that is not enough because they are poor. Their agriculture may increase, but they don't know how to sell it. So local cottage industries also we set up. We built one building called it a process plant where cottage-based industries have been built, which is being managed by the local village people. So that was the work. See, one village was having a lot of cattle, and you see it is quite dirty lane here, lying, cattle dunks are lying. And no wire you can see. It is not electrified, except the NGOs have put one small solar. They were charging at 100 rupees per kilowatt hour rate. And that was one difficulty to convince them that our rate will be even less than the utility rate. So we did a lot of meetings and we could convince them. These are some of the initial meetings with the ladies in the village. You can see myself here. And then after a lot of effort, we got the panchayat land in 2 hamlets. And this is the groundbreaking ceremony taking place. And the person who is doing is myself itself. And she is the actually Gram Pradhan. Her husband is standing here. And the utility has brought now the transformer and put the wire to the village houses. Now, when we formed society, it was difficult to convince them. A lot of meetings took place. And finally, they signed the document, Gram Panchayat people, and it went off. So finally, we went for, in one of the village which did not have the kettles, we went for 70 kilowatt of solar and 100 kilowatt hour battery energy storage. This was lithium ion. And then the other village, we went for 30 kilowatt solar, 30 kilowatt biomass. We said that we will produce the power as well as we will also produce we will also produce the fertilizer, solid as well as liquid fertilizer through biomass. So this is the picture of biomass process where cow dung they had also a lot of wooden waste. So that also can be fed into this. And through one chamber, we take through feed pump where the biogas is produced. It is basically methane gas, which is stored in a balloon. And then we remove the hydrogen sulfide scrubber is there for water removal system. And then from balloon, we run the engine, which generates the power. And from the digester, we also get another output, which is mixed of solid and liquid, which we separate. So solid and liquid fertilizer is separated, and that is being marketed by the village people themselves locally. So in feed and also the fertilizer selling is their responsibility. Another society have been formed. So I'm just still talking about how it becomes sustainable. A lot of efforts have undergone. So, but we wanted to interconnect the two microgrids. Since there are two AC microgrids, so it is getting AC supply from local grid, so it can operate independently as well as grid connected. And then we wanted to interconnect so that dependence on the grid is minimized. When you have surplus supply in one, it can be fed to another hamlet. And microgrid energy management system was put to control everything and also send the signal to our control center at our campus, which is 45 kilometers away. Okay. So since it is, you want to synchronize, they may be at different frequency and voltage. To take care of that, we have gone ahead with AC, DC, AC converter. Okay. So that is the design we have followed. So as I said, we provided solar pumps, which has increased their agriculture yield. Cottage industries also we have set up, and it is being managed by the ladies community. And then we have also done the post installation survey, and we got the very good feedback about the availability of power, which is now 24/7. And it has actually a lot of things have happened apart from the increased revenue generation and also the crop yield. Children education also is improving because now they have 24 hours electricity. So this is the actual picture. Now biomass plant, you can see on the top left. We are also giving them training about biomass system. And then our project monitoring team is at site. This is the solar pump. This is the solar installation. And this is being explained to various people who are visiting here. Control room and one process room. Similar room is there where cottage industries have been set up. And whenever we conduct a training, we take them to our rural pilot and show them. Okay. So that is one very successful project. Now, second one was inside our campus, which is a replica of semi-urban. I will, I think, take another 10 minutes. So 30 kilowatt solar, we have 30 houses. Actually, these are the two lanes, adjacent lane, which we are being fed from substation by two feeders. But they can be, in case of failure on one side, the other can be connected through a isolator here, auxiliary switch here. So these are the feeder pillars. And this has a large lane is there, but only 30 houses we have put solar, 5 kilowatt each. And battery is centralized. We did some optimization study and looking at the site, we decided that in the two feeders of our substation, we will put the battery, one of 140 kilowatt hour, other of 100 kilowatt hour. Optimal sizing we have done, looking at the peak load and other conditions. We also installed EV charging stations at two places. This is our actually lithium-ion battery in substation. This is one of the houses, rooftop is there. So we also have the fast charger, DC fast charger, AC charger, and also the vehicle to house charging, bidirectional charging, and then auto rickshaw charging, along with 25 kilowatt solar so that we don't take charging power from the grid. That is the trend which will come up actually. So a smart charging system will have local sources. And the whole microgrid in the campus, semi-urban and urban, I'm going to show, is being controlled through microgrid controllers. Now, this is the urban one. So urban in two installations, like urban area, you have tall buildings, multi-story buildings. So we have multi-story housing. So where solar as well as the battery have been installed. And we also went to one of the institutional building, where thermal energy storage we have installed. I'll talk a little more about that because very, very useful technology for energy saving. So 25 kilowatt solar and 50 kilowatt hour battery in the two towers. The idea is that during daytime, battery and solar is enough to take care of the loads locally. But during nighttime when solar is not there and if power goes up, our dependence was on diesel generator. We don't run that and take the power from the battery. That was the overall idea. Now, coming to thermal energy storage. Now, this is a technology which is not electrical system. So it is in the chiller system of the air conditioning plant. So we have tried for air conditioning support. So we have tank which can be overhead or it can be underground. In fact, we had underground system which was not operating. We made it operational, 230 ton hour, and this is 545 ton hour. So totals 575, 775 ton hour we have installed. Now, the basis was that the peak load is about 150 ton hours, so at least 5 hours we can run the air conditioning system through this once it is cooled down. So I'll just briefly tell about the operation. The operation is that it is filled with glycol solution with phase change material. I think this is the material like nodules you put. The property is that with putting the phase change material, the liquid inside remains liquid at a lower temperature, -10 up to -10 degrees Celsius. So during off-peak hour, let us say night time, it takes the chilled water through central chiller plant and cools it to -6 degree or -10 degree. During daytime, central chiller plant is shut down, and this supports the air conditioning system of the whole building. It is very successfully operated. For any urban area, I think this is going to be game changer, and people should go ahead with this kind of air conditioning support. And we have seen the comparison. 19 was without, before it was installed, load requirement was very high, peak load, which has gone down. The energy consumption has gone down. In 21, we have compared because 20 was the Corona period where this building was closed. So 19 and 21 comparison we have done. So it results into energy saving and also reduction in peak load. Now, another important development in this project was the advanced distribution management system. This is totally indigenous because we have G system, ABB system, where they don't give you access to add any software. The architecture is not that open. So we decided that very open architecture we will use, plug and play type of software. Any software you can add on your own. So we already, our campus was under SCADA. So we also added one enterprise service bus through which the meters were integrated, and ADMS have been integrated here. Now, all the software, which is whether it is for state estimation, power flow, fault location, the service restoration or reconfiguration, that was developed jointly by our team. The algorithm we gave, and the industry partner actually converted into the interface friendly software. So we have GIS system, we have outage management system, meter data we can integrate, weather forecast it can give, and we can also conduct training on this particular platform. So this is very important development which has taken place. Now, all the microgrids, 2 of them, 3 of them are in campus and also in village. They are giving signal being acquired at this control center. And centralized control also, some of them are possible. Actually, optimal power management is possible remotely. So this is working very successfully. Now, as I said that in future, when the network become totally active, large number of DRs are put, the DISCOM has to go for wide area automation and IT infrastructure. That is the basic requirement. And system operator concept has to come up. System operator will not manage the network. Network management will be the distribution company, but system operator will be responsible for minute-to-minute balancing, prediction of the load as well as renewable output, and also maintaining the quality of supply. So as it is happening in the transmission network through Grid India. Now, are also the SLDCs are to some extent they are doing. Now, we brought out a white paper because this was one major effort, not part of our project, but extra work we did, which was actually endorsed by the Ministry of Power and Ministry of Science and Technology. And this is the launching day, which came up. In fact, you can download at this site, this white paper. 8th May 23, it was launched at NIT Jaipur. So it carries out normal DMS operation like network operation and then network planning, scheduling, dispatch, but it also ensures resource adequacy, forecasting tools, market facilitation, ancillary flexibility service it will provide, and it will result into several advantages, including helping the country in achieving 2000 by 70 net zero goal. Because when large deployment of RES is there should be some agency to manage it, integrate it. There may be local market, need for local market, which has to be created. So that has to be managed. Flexibility in distribution has to be shared with transmission. So that also is required. So strong communication between transmission and distribution is also required. So this is a very important document where we have given 4 different models depending on the state of various utilities, that which utility should follow which model, that also have been highlighted. So whether it is partly DSO or full DSO, so that has been explained. So I will encourage you to go through this document, very important document. Now, country has already gone ahead at transmission level. The renewable and management system, energy management centers at 12 places, 3 regions, 8 states, and 1 national level control center. These are the states involved. And also 1 at Andaman. So they are doing the forecasting very regularly of renewables. Renewable management, they are integrated with the normal control center also. Okay. So this number will increase as the deployment of renewables are going to increase at transmission level. But DSO will be required at the substation level. But this is actually part of the Grid India, which is the system operator at transmission level. Now, this is the last main slide. Very important document have been published in 24 by US Department of Energy. Looking at the changing scenario which is taking place due to this net zero goal and also the lot of renewables being deployed, what are the future R&D efforts required? What kind of testing platform and validation platform to be developed? What kind of demonstration pilots to be tested before it is going to the field? So they have divided into 6 pillars. One is the effort required at device level or system development level. Device includes power electronics, energy storage, integrated energy systems like the heating and your electricity, they have to combine. And even the equipments, because now the saturation had come earlier where a lot of high voltage equipments were not being procured. So manufacturer side is stopped manufacturing that. In fact, this is going to be the biggest problem. Transmission system, when we are expanding, now we are not getting the equipment in time. So how to take care of that? Then operation at transmission and distribution level, integration is required. As I said, that flexibility has to be shared, resources have to be shared, voltage support has to be given between the two. Flexible grid management, so this requires a lot of sensors, measurement, data analysis, production and control. Then planning at different level, whether it is data science utilization for forecasting or climate-based adaptation, or the behavioral science is also involved, because this is very important to know. To exploit the flexibility of at loading, behavioral science is required. Then various policy and market design has to take place. Cyber security, microgrid for physical resiliency, has to be promoted. And as I said, flexible generation and load are required. So this is very important document. Whole roadmap, who will be involved, have been given. I think there is a need in India also to develop such initiative where all stakeholders have to be involved. So remember that the change which is happening cannot be tackled alone by power system expert. It needs market expert, it needs cyber expert, it needs the economist. Everybody has to come together along with utilities, industries to take this responsibility. Just to conclude my talk, the smart electricity grid will have large deployment of these sources, renewable sources, predominantly solar PV and wind worldwide. I think they are going to take place, which will ensure decarbonization and energy security. It will have power management and stability challenges, which can be met through proper converters and controls to be designed. And to take care of variability and intermittency, flexible load or generation or energy storage support will be required, along with proper controls. As I said, India is already moving ahead with net zero goal by 70, and e-mobility drive is there, long e-mobility drive is there, with integrated planning, market mechanism, and renewable energy management centers at transmission level. At distribution level, ADMS and DSO need to be deployed, and grid modernization plan, as you have seen by DOE, need to be worked out in our country as well, which will leverage the resources in transmission and distribution level. So that's all from my side. If you have any question, please do ask.
If anyone has any question, you can raise your hand.
So if you want, I can stop sharing, or maybe I'll keep my slide on. Hello?
Yes, sir, no problem, sir.
Yeah, please. Anybody has question?
You can ask your questions. Raise your hand if you have any question.
Kishore Patil. Introduce yourself. Kishore?
Yes, sir. Good evening, sir. Myself, Kishore Patil, head of the Civil Engineering Department, SD Bansal College of Technology, Indore.
Great.
I have no question, but I have some submission that in Indian references, we have to more focus on the solar energy.
Yes, we are focusing, yes.
As we have the maximum population in the world, and we have to produce the energy from the rooftop solar system. And I, as a civil engineering person, I am having the feeling that every person should go for the solar rooftop, as construction price of rooftop houses is about 50 to 60 lakhs, and there are different policies government is encouraging by the solar Surya Ghar Yojana, Pradhan Mantri Surya.
So you rightly said, I should have mentioned it. Surya Ghar Yojana, PM Surya Yojana, or Mufti Bijli Yojana they call, about 1 crore houses. The rooftop solar have been planned. So government is giving subsidy for that.
Metropolitan city, and we the persons, we are already educated, we should move forward so that the costing will be reduced as the number of users will be increased, and obviously we will contribute to the Indian development by 20. Thank you so much,
you
sir.
rightly said. I think rightly said. The government has that plan also. They want to promote. The only difficulty is our manufacturing side. has not caught up that much. Suppose you have to now procure. Will you only depend on China to get the solar, or can you produce locally? That is the big question. So manufacturing side has to be strengthened. So make in India or made in India has to be enhanced quickly, actually. And similarly, the storage actually that also has to be developed locally. So we should not only depend on the other countries to supply. So but the current plan, PM Surya Yojana, is without storage. The subsidy is right now without storage, but probably that will be extended. So up to 3 kilowatt you can install and get some subsidy. Yeah, that is there being promoted. But apart from that, the plan was to go for a lot of rooftop and the large installations also. Dr. Bharat Rawat. Dr. Bharat Rawat, please go ahead. You unmute yourself. Dr. Bharat Rawat. Bharat VPS Rawat. Your hand is raised.
Sir, now I'm audible.
Yes, please. Yeah.
Sir, my question is that.
Who are you? Introduce yourself.
Sir, myself, Dr. Bharat Rawat, Bharat VPS Rawat. I am from JB Institute of Technology, Dehradun. I am Research and Development Coordinator in my institution.
Great. Yeah.
My question is about the manufacturing aspect of the solar panels.
Yes.
We are going for the manufacturing and we are following China for all these aspects of manufacturing. But what is the procedure or what is the method to recycle after the whole lifespan, that is approximately 15 years, approximately, I think so, as I come to
Yeah.
know.
So silicon
what is the-
material recycling is tricky. I think already policy has come up. So there are agencies actually who are doing this job. So, but at least the life is 15, 20 years. And recycling, actually, a lot of startup have also come up now. So they are taking up this challenge. So I'm sure in future it will be solved. But challenge right now is to go ahead with the installation. High efficiency solar panels, like monocrystalline or many new things have come up. How do we manufacture quickly to meet the demand or to meet the goal of the government of India? That is the biggest problem. Yes.
Sir, but what is the impact of those substances on the environment when we recycle them? Because already we have
No,
discussed.
that I think the recycling experts have to take care. So I'm sure they are working here. We have seen some of the startups actually, they have come out with very bright ideas actually. How to restore those material from the waste and reutilize it. So that is there. Recycling is that process, yes. The efforts are there. That it's not very easy, but it is being done. Yeah.
Thank you, sir. Thank you, sir.
Okay. Anybody else? Mohammed? Maruf Ahmad. You want to ask something? Oh,
No, sir. Good evening, sir.
good evening.
Sir, it is immense gratitude, sir, and deep appreciation that I extend our heartful thanks to our esteemed sir. Sir, you are profound insight, expert knowledge, and inspiring presentation.
You are all actually
Yes, sir,
the
I'm from
torch bearer. So, yeah. So it's a great pleasure interacting with you. If you have any question, please ask.
no, sir, I have no question.
Okay. Anybody else, please?
Anybody has any question, you can raise your hand.
No, I think there is no question left.
Okay, sir.
Rajesh. So should we
Yes.
close?
Yes, sir. Thank you very much, sir.
So it was great pleasure interacting with all of you. Please post your question. You can send through email. I'll be very